Okay, welcome to another quick Python tutorial. Today we're going to talk about Python lists. There are 4 different collection types in Python anyways. A list is an ordered and mutable collection. That's why we're going to spend the most time with it. It is indexed. We are able to put any kind of information we want in it as long as all the information is of the same data type. But the other collection types that you have are tuple, set, and dictionary. Tuple is very similar to a list, but it's immutable. Once you build it, you can't change it. A set is very different. A set is an unordered and unindexed collection where there are no duplicate members. So basically, it's just a container for unique things. And a dictionary is unordered. It can be indexed. It's mutable, but most likely you access it by key value pairs. So you assign some sort of keyword to a value, and you can access information through either the keyword or the value. So list is going to be as similar to most other programming languages, array data types and things of that nature. So we're going to go through list and we're going to stick to that because it's going to fit our needs the best. So to build a list, it's actually pretty easy. We just make sure we put the data that we need inside a square bracket notation. So I'm going to come up with a list of test scores. And I'm going to say test scores is equal to, say, 90, comma 85, comma 100, comma 64, comma 82. Okay, so I've got 5 test scores here, and they're all locked in. So I've got one variable that holds on to 5 different pieces of information. I can access that information relatively simply just by saying test scores. I'm going to copy that real quick just for ease of access. And I'm going to go test scores at 2, okay, and it produces the 100 because remember, indices always start at 0, just like they do with any sequence in Python. So 0, 1, 2, there's my 100 for what I want, okay. If I said simply test scores at 4, okay, I would get the last member. Okay, because remember there are 0-based indices, so if I've got 5 test scores, the very last one happens to be 4. If I attempted to access something at 5 or beyond, I'm going to get an out of range error because I can't do it. Now I could also index them in reverse order, so if I ever wanted the last element, I could say -1 and it would give me the last element. And I can slice it, so I can grab chunks of this. So let's say I said test scores at 2 to the end, okay? It would give me a copy of those last 3 scores, everything starting at index 2, 0, 1, 2, 100, 64, and 82. I can pull out like the middle chunk saying test scores at 1 to 3, okay? But essentially it's the same thing as any other collection like we've done, or sequence I should say, like we did with strings and pulling out substrings, but I can come out and do the same basic thing using that square bracket notation again to grab one individual piece, okay, or a range of pieces. So they're all pretty simple. But building, you just want to make sure you put it in square brackets, and then you can access it using an integer with square brackets. Even if that integer is a variable, okay, we can say test scores at index. We can still pull it out and still get that 100, okay? Unlike strings, lists are mutable, which means I can change any one member that I want. So remember I had 90, 85, 100, 64, and 82. Let's say we retook that 64 test because it's in slot 0, 1, 2, 3. We can actually change it to maybe our new score. So if I said test scores at index 3 and I wanted to make it a 90 now, I could say equals 90, and we'll see that my test scores actually changed and updated, so now that 64 is simply a 90. So I can actually go in and change any one member that I want, which is really kind of nice. So it gives me the ability to do that pretty well. Now, most of the time when you've got a collection of things, you're going to want to be able to iterate through each one. There are several ways to do that. It depends on how you want to access the information and what you want to do with it. You can access it with a while loop, where you have to define the index that you want to access and then keep track of how you're going through it. You could also go through it with a for loop in which you don't need to track any of that information, but it makes it more difficult to change and modify said information and do stuff with the index if you need it. So you have to kind of look at the looping structure based upon your need. If you need the index or if you need to modify the information that's held within, you're going to need to use a while loop. If you're going to use it as kind of a read-only purpose, then I would use a for loop. To give you a demonstration of both, let's say I said index equals 0, okay, and I can say something like while my index is less than the length of my test scores array, okay, or list, I can then do something with each member at index. I can simply print it, test scores at index, right? And then I got to make sure I increment that index each time, otherwise I'll get stuck in an infinite loop. So plus equals 1. This will stop once it gets up to the length of index, and so you can see that it prints out each item very, very neatly, very, very nicely. I can do basically the exact same thing as well to print them evenly going horizontally. I can do that. So if I bring this all back and I just change how my print statement works, let's say I say end equals a space. And now if I kind of come through, it'll print it out horizontally. Now, that's all fine and dandy. That'll allow me to grab information and do certain things with it. Like, let's say I wanted to keep track of a certain number of A's. Like, how many A's did I get in this, a 90 or above? Well, I could do that pretty easily. I could say something like index equals 0. And I could say while my index is less than the length of my test scores array, I could say something like if, okay, my test score at index is greater than or equal to 90, okay, I could just print that score and then kind of keep track of which one they are, or I can say which tests got a greater than 90, so now I'm actually using that index, so I could say something like this, print test, let's see, at index, was an A. Now remember, this is going to be 0 based, so it's not going to say test 1. It might say test 0 or something like that, but we can manipulate that a little bit later if we really, really needed to. And then I would want to go index plus equals 1, and then I can go through it. Whoops, I had test score is not defined because I spelled it wrong. So let's put this loop back together, and test scores. Let's try it again. And it says it was an A. Oh, what did I forget? Well, see that index plus 1, it's inside the piece. I'm stuck in an infinite loop here, so I'm going to want to get out of that as best I can. Let's see, how do I do that again? There we go. Had to interrupt that. So here, if I wanted to do this, be sure that you are putting that incrementation statement, not necessarily in the if statement, but in the loop itself. That's important. So simple mistake to make, and something you're going to want to be mindful of as you're kind of going through and making sure that you're working your way through that. So there I've got my A's kind of printed. Works out pretty well. Now the for loop is what we're going to want to make sure that we can go through as well. The for loop is a little bit different, so instead of accessing things by index, you can access each member directly and capture it. So for me, it could be something like for score in test scores. Okay. And what this does essentially is it loops through all the test scores, no need to keep track of the index or anything like that. It'll always start at the front and work its way to the back, and it will take each score individually and pump it into this variable score that I can use. I can say print score. And notice it'll go through it and it'll print each individual score as we kind of make our way through. So you'll have to be very careful with that. All right. So the for loop is a really nice loop, but it kind of works as a read-only loop because you can only do things with each individual element as they go through. You don't have access to the index, and if you don't have access to the index, then you can't make changes to it per se. So you'll have to be very, very careful with that. All right. All right. So we've got our test scores. Let's talk about what we can do with lists. There are lots of built-in methods that allow us to work with them. Len, print, max, min, sum. I'm not going to do all of these, but I'll show you a few of them. And then there's also other methods that you can work with. Append, insert, remove, pop, count, sort, reverse. There are also others that you can work with as well. So we still have our test scores array. Let's simply print out the len of test scores so you can see what that does. Lost my copy paste, so it prints out 5 because there are 5 elements in it. Okay, I could just print test scores, which you've seen me do already. What it does is it prints it with those square brackets. It kind of just shows each element, which is really nice. Now you can even find like the max of test scores. There are lots of built-in functions that allow you to do that. And min of test scores, it'll produce the minimum of it. 82 for right now. You could even sum test scores. It'll print out the overall sum of it, so making averages and things can be really easy. Now, those are just the built-in functions to Python. Notice they're all kind of purple. There are methods and functions you could apply directly to the list. Like, let's say we took another test and we want to add another score to it. Well, this is what we call appending. So I'd want to say test scores dot append, and then I can put in the value that I want to append. Let's say we didn't do particularly well with this particular test, and now we get a 70 in there. We can throw it in there, and if I simply print the test scores, you can see exactly that it added the 70 to that test scores as we wanted to. If I want to insert a test score right into the middle of the array, I could do that as well. So let's say I said test scores dot insert. Okay, to use this method, you need to tell me where you want to insert something, so maybe at index 2, and what you'd like to insert. Let's say I want to make sure I insert a 90 into this. And so you'll see that at index 2, it inserts a 90, and everything from index 2 beyond now got pushed down a full index. And so index 2 is now a 90, and everything else got pushed down from what it once was. It was 190, 82, 70. It still is, but they're one further index down. Okay. Now let's say I wanted to remove that 90. Okay, let's go test scores, remove a 90. I can just simply type in what I want to remove. Now the thing about the remove method though is it won't remove the 90 that we just put in, it'll remove the first occurrence of the 90, which happens to be in the very first instance of this, so it removed that 90 right away. If I did another one, it would remove this 90 here. Okay, so if there are multiple of them, it'll remove just the first occurrence. Now, if I did want to get rid of this 90 that's right here at index 1, I could pop it. So I could say something like test scores dot pop index 1. And what it'll do is actually pull it out. Now you notice it actually printed something as well, because the pop method returns something to me. So I can actually catch what it got out of the list in another variable or part of a method argument or whatever it is. And it will remove it from the list, but also give it back to me for use in some other way. So here it returned the 90, and you can catch that any way you want. But again, if I printed the test scores, you can see that the 90 at index 1 is now gone, and everything has kind of come up through. Okay. So let's go ahead and put that 90 back in. So I'm going to go test scores, append a 90, just for the next sake of demonstration. Let's say I wanted to count all the 90s. It'll tell me how many 90s there are in the list. There are 2, okay? I can now sort the list as well. So if I go with test scores dot sort, okay? Notice that doesn't do a whole lot right there, but when I print it back out, now it's sorted in ascending order. If I wanted it in descending order after it's been sorted, I could reverse it. And reversing just simply puts it in reverse order. And now you'll see it's in reverse order. So there are lots of things that you can do with lists that you can work with, and of course you can put them in great many different contexts, but there's the basic idea, is that you can do lots of different things with them. So obviously if you're using some built-in function, you call the function pass test scores in as the argument, because these functions can be applied to lots of different things, and once you apply it to a list, it knows how to deal with it. If you want to use these list methods, you have to name the list first, the method, and then what you want to do with it. So follow the documentation for that. So you can either look here at the notes that I've given you, or feel free to click into the actual Python docs and work your way through that. But either way, lists are really easy to work with. They're a nice grouping of lots of information that you can access in a great many ways. So use it appropriately, and we'll see you in the next video.